God's best and God's blessings be to you, Algebra 2 students. I would like to share this video with you in preparation for tomorrow's quiz. I trust at least some of you will be able to see it. And we ask you, Father, to lead us and guide us because you're right here with us. You have not left us. You will never leave us. So we trust you that this will be a very fruitfully spent time in Jesus' name. Okay, your verse, which encourages you to believe that you can excel in this quiz. Only 7 words to that one. 7 words from the great book of Genesis 18:14. Say it with me. Is anything too hard for the Lord? Again, is anything too hard for the Lord? And then we move into the solving of exponential equations. One thing I'd like you to remember is the main strategy or objective is to have the same base on the left as you have on the right. And I'm sure you'll agree that we do have it. We have base 4 on the left, base 4 on the right. And once the bases are the same and they're standing by themselves, we can pretty much just strike them out and do what? And set the exponents equal to each other. So we have 8x minus 5 equal to 5x plus 10. And then it's just a matter of carefully doing the algebra and solving. Right? So since the 8x is bigger, I'm going to subtract the 5x from both sides. And when I do, I'll get 8x take away 5x is 3x minus 5. Over here, when I subtract the 5x, I'll be left with only 10. And then what? Add 5 to both sides. So when I add 5, this 5 is gone. I add it because this is minus. So then what we left with would be 3x. When I add 5 to the right, I'd have 10 plus 5 would be 15. When I divide both sides by what? 3. Then I get x equals 15 divided by 3 is 5. Okay? This one, what do you think? Well, I got a base 5 on the left, but I don't have a base 5 on the right. But not to worry. We can always seek to get the same base on the right. So here's a question. 5 to the power of what will give me 125? That's going to be the key. So you're asking this 5 to what power will give me 125? Because this is base 5 here. I'd like to get the right side to be base 5. So you have to go to work and say 5 times 5 is 25. 25 times 5 is 125. So that's 5 to the 3rd power. So the first step here is to express the right side also to the base of 5. So that'll be 5 to the 3. Okay, sorry I didn't make my 5 better here. Is equal to 5 to the 2x plus 6 plus 6. The bases are now the same. So I can strike them out. And I'm left with 2x plus 6. I don't want you to skip any of these steps. I might skip 1 or 2 here because I don't have my pen to write with. I'm sorry, and so I'm going so painstakingly slow. 2x plus 6 equals 3. And I want you to work it as well. Work it on paper as I'm doing it, and you go faster than me. I'm subtracting 3 from, not 3, but 6 from both sides. And when I do, I get 2x is equal to 3 minus 6 is what? Negative 3. When I divide both sides by the 2, I get x is equal to negative 3 divided by 2. Negative divided by a positive is a negative answer. Negative 3 over 2. Alright? So that's another type. A little bit different, a little bit more thinking here. You have to think how you can make the right hand side to have the same base as the left hand side. So it's 5 to the watt equals 125. Number 4 is going to be a little bit different thinking. We have 6 to the 2x minus 7 equals 1. So here we have a base of 6. Over here we don't have a base of 6. What should we do? And I can just hear some of you saying, oh, I know, we can make the base on the right side 6 also. But then it would be 6 to the watt. 6 to the watt power would give me 1. I hope you remember. Yes. I can't hear it, but I can imagine it. 6 to the 0, right? Exactly. So write that down. Don't skip this step. Remember, you might fall and trip and hurt your ankle like I did. 6 to the 2x minus 7 is equal to 6 to the 0, which is 1. Now, again, I can strike the bases because they're the same. And I'll be left with 2x minus 7 is equal to 0. I add 7 to both sides, and I get 2x is equal to 7. Divide both sides by 2, and I get x is equal to, so it should be an equal sign, 7 over 2. Okay? You can put the steps in there, which I didn't put. I could put add 7 here. How about some logarithmic types? Solve the logarithmic equation. Got the first one, which is the basic. Log of something equals log of something else. Once you have log only on the left, log only on the right, you can do what? Strike the log, and you'll be left with just what is called the arguments being equals 3x minus 9 from the left will be equal to x plus 3 on the right. And then you solve it by algebra again. X on the left, x on the right, we want to put the x's to one side, so we subtract x from both sides. Since this 1x is less than the 3x, we subtract x, and when we do 3x minus x, we get 2x. You can put the minus x under it. I'm just doing this to save myself a little bit because I don't have the ease to write as I'd like to. So it's minus 9 is equal to 3. Then I'm going to do what? Add 9 to both sides. So I get 2x is equal to 3 plus 9 is what? It's 12. Somebody can give me the answer. I can just hear somebody shouting the answer. What's the answer? I divide both sides by 2 and I get x is equal to 6. Okay? So that's so much for that one. Let's take another one. Logarithmic again. Can I just strike the logs and then set the parentheses equal to each other? No, I'm glad you see it's no. Why? Because it's not log only on the right, log only on the left. I got log minus log equals 3. And when I have log minus log, then that will guide me to what is called the quotient rule. So it's going to be a division. So it's going to be log to the base 2. And it's division now of 2x plus 5 divided by x. Let's put that in big parentheses. Is equal to 3. You can see this is different. It's not log on the left equals log on the right, where we have log only. So what should I do here? I've got log on the left equal to a number on the right. Did I hear somebody saying exponential form, exponential form, exponential? Good. That's exactly it. So it's going to be 2 to the third power is equal to 2x plus 5 over x. And that's how we will set it up to solve. 2 to the third is 1. That's going to be 8. Any number is that number over 1 is equal to 2x plus 5 over x. And we can cross multiply now, like this. Okay, and 1 times anything is the thing itself. So it's going to be 1 times 2x plus 5. That will still be 2x plus 5 equal to x times 8 would be 8x equals 8x. And since the 2 is smaller than the 8, I'm going to subtract 2x from both sides. Not 2 now, but 2x. So subtract 2x from this side, it will be gone. Subtract 2x from the right side will leave me 6x. 6x equal to 5. And then what? Divide both sides by 6. When I divide both sides by 6, I get my answer. 5 over 6 equals it's gone. So x is going to be equal to 5 over 6. Alright? So one more. This was the subtraction type, which we work by dividing. How about the addition type? What should we do? Addition type we work by multiplication. So here we go. It's going to be log. This time the base is 5. And now this would be 5 times x. 5x. Okay. Let me keep it in parentheses separated from the base 5. It's equal to 2. And now what do we do? I'm minded to just have you finish this one out because I'm sure you could. Can we strike out the log from both sides? Uh-oh, we don't have log on the right side. But not to worry, we can revert to the exponential form. What is that? That would be 5 to the second power. 5 to the second power equals what? Equals 5x. Alright? What is 5 to the second power? 5 to the second power is 5 times 5. That would be, I'm just going to switch sides. 5x equals 5 to the second power, which is 25. And now divide both sides by 5. And 25 divided by 5 is 5. So x in this one will be equal to 5. Alright? So I trust this review is helpful. May God guide you. But don't stay up too late tonight. And get some good rest. And I look forward to seeing you soon. Bye-bye.